I don't see the chat.
It's there. I can access it. So participants are joining now. Sorry for the delay, everyone. We're having some technical difficulties on our end. We finally got it figured out. So we will be starting here momentarily.
All right, so we're getting some participants logging in. That's wonderful. How many we got so far there, Bernie?
41 so far.
Well, I'm glad that folks have found the time correctly. We were a little concerned about the Eastern Standard versus Eastern Daylight Time, but I think that everybody's in, and we can probably start this off, Tom. I'm looking forward to this webinar. We've worked with SunSpec just a couple of months ago in doing some rapid shutdown stuff, and we're going to be going through our CSIP certification and rapid shutdown today. So I'm glad that all of our participants are joining with us. We've got a lot of great information going, and I think we can start up here. The name of this particular webinar, this is webinar number 8 for Jinlong Technologies. Jinlong Technologies Co. Limited is the name of the company. The brand name for our inverters is Solis Inverters. And with SunSpec today, we're going to be talking about the importance of the SunSpec CSIP certification and what that means for PV system installers. It's quite timely, as we have seen the June 22nd date go by, and we've seen a lot of inverters no longer in compliance. And so we want to talk a little bit about that. Jinlong is a member of SunSpec, of course, and SIA. This webinar will earn you a point in NABCEP, and we see a lot of great work coming out of the California Solar and Storage Association. We highly recommend you join that group. Today, me, Terrence Parker, joined by my colleague Bernie. Hey, good to see you, Bernie, and glad you could join us today. And as a special guest, we have Tom Tansey, the CEO of SunSpec. Hey, Tom, thanks for joining us today.
Thanks a lot, Terrence. Glad to be here.
Well, Tom, today I'm just going to go through a short introduction of our company and products and get right into SunSpec and what your work is doing to drive the adoption through standards and grid codes. And then we'll kind of get into how the grid is evolving a little bit and what that means and how that's changing things for installers. We'll talk about what is CSIP and talk about whether or not your inverter that's CSIP certified is at CECs listed and how do you check that all out. And then we'll go through a Q&A for everyone who's curious about these topics and what's changing in the industry today. Let me just briefly go over Jinlong. You see a photograph there, or an artist's rendition of a new factory that we're building. And indeed, Jinlong Technologies builds their own factories. We operate our own factories. There's no contract manufacturers involved here. We were established in 2005, and we are a publicly traded company. We trade on the Shenzhen Stock Exchange. Our stock code is down there at the bottom in the small print. But what we're doing in this new factory is quite unique in that we are developing it for real flexibility. We can change from single-phase inverters to three-phase inverters quite quickly on the production line. And we've automated a lot of these processes to even keep, to ensure quality control and keep a lid on costs. That's really the result of us operating our own factories. Of course, we're ISO 9000, 14001 certified. And one of the interesting things you'll see in this factory is a 100% burn-in of our products before they're boxed up. This is really one of the signature techniques that's used by Jinlong to ensure no DOAs on your sites. And indeed, we do have a proven reliability record. That's something that I think our string inverters can brag about, in that we have product in the field for more than 10 years. And to date, over 12 gigs shipped. We've got about over 5 gig capacity today, and we're expanding with this new plant up to over 20 gigs. These products have been third-party validated by PVAL, not only for reliability, but for their performance. And indeed, that's part of what we talk a lot about, is the reliability of our performance. and we track that very carefully. We have a service team developed here in North America and now spread across our entire or a global organization. You can see that we're answering the phone within a minute, and typically our engineers online, our tech engineers online, can solve your issue within 6 minutes. You know, there's other service organizations out there, but we've tried to really focus this on what the installers are calling about, what they need, and the kinds of fast kinds of services that we can provide that will get you done in one truck roll. And we keep statistics to back this up. So we look forward to you calling and talking to us about any of the systems that you have going. And you can also reference our website and see a lot of great product there for you to review before you go to a site on troubleshooting or inverter product lines, whatever you need. So with that, I'd like to introduce Bernie Grant, our three-phase product manager, and he can start with our single-phase products. Bernie?
Good afternoon, Terrence. Welcome everyone to the webinar. Please ignore my son in the background. He'll leave eventually. He's kind of creepy. Our single phase inverters, we actually have a fairly broad range of inverters designed specifically for real use, a 3.6 and 5 kilowatt with a dual MPPT, and then a 6, 7, and 10 kilowatt in a larger class. These are designed to meet all your customers' needs without having too many choices to choose from. The MPPTs, what's interesting about our company versus other companies is our maximum power point trackers are fully 100% independent. So that gives you a little bit of flexibility in design. You don't have to worry about whether or not you have 9 or 10 panels on every string. You can have 2 of the strings on this big unit have 10 panels, and one string have 4 or 5 panels. It still operates very efficiently, and it's designed to help with complicated roof systems where you may have different portions of your array facing different directions. Fast, easy to install. Our brackets are some of the simplest brackets in the industry. Literally, it's just an easy way to hang the inverter on the wall and secure it. And then we have integrated our rapid shutdown inside the wiring box. We have both SunSpec rapid shutdown integrated, as well as I was looking to integrate the Tigo transmitter as well to give you a lot of flexibility in your needs on the rooftop. We also have the option of having a revenue grade meter inside. That doesn't affect everyone, but some utilities require the customer to have a meter that gives them real data back and not an estimate like the inverter currently does. So with that revenue grade meter, it gives them an exact amount of what they're producing that they can use to compare with their bills. Again, all of our inverters are NEMA 4X enclosures as well, factory tested, every single one using a test method for checking to make sure that they maintain that before they're shipped out. Our battery storage inverters are quite a new line, high voltage inverters that work about nominal 400 volts from the battery side. Very flexible, again, 5 kilowatt to 10 kilowatt. They're battery ready. We have cooperated with battery suppliers. That way they're already set up and ready to go, certified together, so you can install those with confidence that they're going to work out of the box. 3 main operating modes: a self-consumption mode for those who want to maximize their solar production, a time of use mode for markets like in California, where time of use charges are quite different between daytime and nighttime. And then you have an off-grid or backup capability. We actually have 2 separate ports on the bottom of the inverter. One can be connected directly to any type of local loads that are critical, like your refrigerator, maybe your television, some lights. That way, if you do lose power, you can still feed the family and see what's going on in the dark. This color screen is really cool because it actually shows you the direction of power flow, whether it's coming from the grid, coming from the solar, or coming from the battery. So it gives you a wealth of information right there on the screen. It also is compatible with our monitoring platform as well. But for a customer to be able to go out and look at the inverter and see exactly what's going on makes it really nice for them to get that feedback, the visual feedback that, hey, my battery is contributing to my consumption. So it's very good for you as installers, for people to see that and get that feedback. Next, we're going to talk a bit about our commercial and utility scale inverters. But we have 3 major product lines currently. We are extending these product lines. We have some announcements coming in the future, which are very exciting, but you'll have to wait for our next webinar to catch those. Our main product line for commercial 1,000-volt inverters are our 25 through 40 kilowatt and our 50 through 66 kilowatt. Again, these have built-in module-level rapid shutdown transmitters of both the SunSpec flavor and the Tigo flavor. And then there's a 125 kilowatt, 1,500-volt inverter that's designed for small ground mount utility scale installations. And in Canada, I guess they use this also in some rooftop installations, which is very interesting. It's designed as a high performance single input P device, and we'll discuss a little bit about its specifics in a moment. Our smaller inverters, 1,000-volt inverters, are designed with a separate wire box. And this is interesting because it allows 2 separate things. One, you can quickly replace the powertrain if necessary, and you can do a 2-staged installation method. Again, like I said, it has the rapid shutdown transmitter inside, or if you're going to use it on a ground mount system where you don't require a transmitter, you can order it without any transmitter as well, but you still get the separate wire box design. And that's for our 25 through 40 and our 50 through 66 kilowatt inverters. Very wide input voltage range. Again, they have the same flexible MPPTs that our single phase has. We're talking about the high efficiency of our 125 kilowatt. That was the main purpose and design. It's greater than 98% efficiency, as you can see across the band, from about 10% to 100%. It actually has a peak efficiency of 99.1%, one of the highest efficiencies on the market. And it's extremely flexible, bifacial compatible, extremely high DC to AC ratios. It's really a rugged type inverter. Currently, it comes with a direct PD connection. You can see on the bottom of the inverter that has MC4 connectors on the bottom for directly connecting the strings. And we are also launching a future product which would have a single input connection for those who like to use combiner boxes in the field.
Thanks, Bernie. That was a good review of our product line. And throughout that entire product line, you might have noticed that you saw the SunSpec CSIP badge on that entire product line that you just saw, from our smallest residential inverters at 2.5 all the way up to that 125. With that, I'd like to invite Tom Tansey from the SunSpec Alliance to talk a little bit about what the SunSpec Alliance is doing these days, driving standards and other things. Tom?
Great. Thanks a lot, Terrence. Yeah, about the Alliance, SunSpec is a trade alliance. Our mission in life is to develop information standards for distributed energy. We've been growing quite rapidly. We have over 115 members at the time, and over 1,000 different companies that we work with to help adopt open standards. We work across both the de facto and the international standards arena. So SunSpec Modbus and the Orange Button standards are 2 standards that we developed on our own. SunSpec Modbus is now part of the IEEE 1547 standard. It's one of the communication protocols that's supported in that environment. And so our idea in information standardization is to start at the very lowest level, at the machine level, such that ultimately these standards can be used for financing, operation, and maintenance, and the like. Everything that we do is open standard, open source. And so if you go to sunspec.org, you can download any of our specifications at no charge. Next, please. We have a great cadre of members, and our board of directors is really sort of like who's who. I think there are some names that you would not expect here. ARM, for example, they're the maker of the microprocessors that go into every mobile phone. And PowerDash STEM is another company that maybe you've heard of that's involved primarily in energy storage historically, but now getting involved in solar as well, and other name brands that you would recognize. We have taken the path of driving adoption first through de facto standards, but then ultimately through the international standards arena and the grid codes. I mentioned that SunSpec Modbus is now a U.S. national standard through IEEE 1547. We're also recognized in the country of Poland and the country of Denmark as national standards there. And as I mentioned, you can find us in the IEEE 1547 standard. On the utility to DER system protocol arena, which has been driven initially by Hawaii and then California, we've been instrumental in driving adoption for the IEEE 2030.5 protocol and CSIP, which stands for Common Smart Inverter Profile. So this work preceded the 1547 work, and ultimately, I think, fed into the fact that IEEE 2030.5 and SunSpec Modbus were then later adopted as part of the U.S. national standard. So when we get into the conversation today about 23.5 and CSIP, yes, it applies to California, but if you work in other regions as well, IEEE 1547.1, the 2020 version, will be required across the entire country, and 23.5 and by extension CSIP is an option for you there. Orange Button is a financing and operational standard. It's supported by literally hundreds of companies at this point, and this is used for financing and for operations, so we'll cover that at a later time. And the SunSpec Rapid Shutdown, another open standard for complying with NEC 2017 requirements, and supported by a multi-vendor ecosystem, of which, of course, Jinlong is one of those companies.
Right.
Key to our strategy is certification. So we offer standards, the standards compliance and specifications on an open basis. Then, of course, third parties, vendors, manufacturers adopt them. And in order to ensure that these standards are implemented in the correct way, we offer a certification program. And you can see the stats there. The product that's been around the longest for us, SunSpec Modbus, has by far the largest share of the market here. And I think you're going to see this increase quite a bit with the adoption of 1547 in the 2020 version. It pairs quite nicely with IEEE 2030.5 CSIP. Reason for that is SunSpec contributed the information models for 2030.5 CSIP, and so we have 100% semantic compatibility between these two protocols. Why that's significant to you, and I apologize if some of this terminology is foreign, but hopefully in the near term it won't become quite so foreign. The reason this pairing between SunSpec Modbus and 23.5 CSIP is important to semantic compatibility is that typically you'll have the inverters will support a Modbus interface, and then there will be some sort of a gateway device. And here we're positioning it here in the context of SCADA for this webinar, but there's a gateway device that supports the 23.5 protocol. That protocol then is used for communicating to the local utility. And in California context, that's PG&E, SCE, and of course, SDG&E. So that covers the 23.5 and the Modbus, which is the DER system to utility style interface. Modbus is, of course, also used for local area communications. And then finally, the Rapid Shutdown, which is one of our newer standards on the top. And we're happy to announce just this week we've added yet another vendor, Canadian Solar, to support the standard. So you're going to see that category also increase. Overall, all these standards are important because they give the consumer choice. They can help you if you're an integrator with your supply chain issues. This ends up being a lower cost support system and yields higher stakeholder confidence. On this last point, stakeholder confidence, just want to point out that, of course, as you all know, these DER solar systems are long-lived systems. And so that means there's a responsibility 5, 10, 15 years down the road to be able to support these products. And an open standard allows that to happen. So even in the event where a given product line isn't available from a given vendor, you're able to mix and match because of this commonality across the communication infrastructure. And that, I think, was a key aspect of driving this change. The IEEE 1547 standard is to enable this multi-vendor plug-and-play optionality for installers. Next, please. Once you get these systems connected, the conversation quickly moves from how can we make all this stuff work to how do we secure it. And indeed, this is a very important topic, both for us locally, but in international scene as well, for national security, for critical infrastructure. The distributed energy resources, and by that I mean rooftop solar and energy storage, currently has a rather light relationship with national cybersecurity policy. This relationship is going to become increasingly complex as rooftop solar becomes even more successful, because it will occupy a greater and greater fraction of the overall total energy that's generated in the U.S. And so therefore, securing that supply becomes of paramount importance. So recognizing that this was going to be happening, excuse me, go back to the previous slide just a minute here. Recognize that this is going to be happening. SunSpec partnered with Sandia National Labs. Our partnership goes back nearly a decade, but we started this initiative about 3 years to take a systematic approach to defining a security framework for the DER products and services. And so we produced now over this period of time, I believe, 5 important draft standards and information galore on this topic. So if you're interested in this, you can check out SunSpec on YouTube or go to sunspec.org and you can see some of the videos and so forth. If you join the Cybersecurity Working Group, there's a vast library of webinars dealing with the topics that you see described on the screen. Thank you. Okay, rapid shutdown, very important standard. The reason why it's important is that the NEC 2017 is now in effect in 34 states in the United States. Within the next 2 years, the majority of the other states will come on board, but already today there's a requirement for about 80% of the U.S. rooftop market to support this rapid shutdown standard, and that is the ability to de-energize the conductor on the arrays such that voltage can be reduced and down to each individual panel level. When we started this initiative, there were 30 companies that took part in defining the standard. That way we're able to make sure that the standard could indeed be published on an open, even basis. You see some of the stats here about who is adopting, and you can find out more by going to sunspec.org about the latest companies that are coming on board. So you can expect this is a category that will increase in popularity. And speaking of the certification registry, this is a picture of it. You can get to it by going to SunSpec and look for certified products. There you can do an individual search by doing a keyword search. So if you want to select by vendor or if you want to select by category, we have close to 90 products now represented in this library. So there's many different solutions for you to pick from. Our purpose of this registry is for both the 37 jurisdictions and for installers like many of you on this call today to be able to determine exactly what the content is of these various products, which you can do by inspecting the PICs and the certificate, which comes with each listing.
Exactly, Tom. If you look closely at that slide, you'll see under that card for Jinlong Technologies, you'll note that you can click on that certificate there and grab that certificate in case you need it for your package, a submittal package. And I find this registry quite easy to use because I just go down to the bottom here and I'm looking for my my rapid shutdown or my CSIP, or I can just click on that and I get all the products that are there, Tom. And I happen to block out a couple there just so we could focus on this one. But indeed, it's quite easy to use. And Well, I mean, we have also not only gotten the rapid shutdown certified, but you can see that there's a number of other receivers that can work with that SunSpec certified PLC signal generator that we have in our inverters. And so you saw on that last slide that the inverters were registered. And then you can also go and you can check out their registry and see the actual products that are registered as the receivers. And so if you, for example, are using the AP Smart receivers with our transmitter, you can get a certificate for both the receiver and the transmitter from this registry. It's really quite nice. So I just wanted to get into a little bit about CSIP, and Tom is the expert here, and so Tom, stay on the line as I go through this. But really, I wanted to get down with the installers here and talk a little bit about what's going on and why all these things are going on. And truly, you know, when we look at wind systems and hydro, big hydro, that sort of thing, they are typically controlled by the utilities, kind of supervisory control at a remote site for these large generating assets. And PV monitoring on a single system basis is quite common, and all you installers out there are quite familiar with that. You remember the old days where we used to just put meters on the system, and the customer would follow their own data. And then we started seeing all these monitoring systems connected to the system, and gosh, it was kind of hard to even get your last check from the customer without them seeing their monitoring right on their phone. So when this is sort of a new evolution of the grid where we're seeing these kinds of data in the cloud and more control from the outside, from the utility, in which we're participating in stability. And that's really so the SCADA model is really becoming more of common in our PV universe. And so it's under Rule 21 here that essentially, you know, we have these new smart interfaces, these inverters with smart inverters, smart battery interfaces, smart meter interfaces, that sort of thing. That's going to allow an easier deployment of this type of SCADA for fleet monitoring. And you can see, for example, APS has their fleet out there directly controlled by the utility. And you'll see more and more state and local utilities incorporate these solar assets, energy efficient assets, energy efficiency assets, battery storage assets managed by these supervisory control systems using communication standards like the 2030.5.
Terrence, I'd like to actually weigh in here. So in this case, as you said, the SCADA is a model. And I think that's an important statement for distributed energy resources for residential systems and commercial systems. They would not have what you would classically call a SCADA. And what I mean by that is SCADA really implies something where there's local control and there's a human being that is providing that control. Now, the functionality that is being provided is very similar. In some cases, you might say it's identical. But the difference is that with distributed energy resources, there's no people on site to do any of the management. And so that means that these intelligent devices on site, yes, they're going to connect with a control room like you see there. And the control rooms predominantly are going to be those of the three main utilities, and they'll do all the normal operations that you would expect. But I just did want to make that point clear that when it comes to rooftop and commercial installations and Rule 21, what really is implied here is an unmanned operation. So where you have these intelligent devices doing a lot of the work for you and communicating to the operators from afar.
Thank you. And to continue with that, you know, utilities are also using these companies called aggregators. And I kind of wanted to get a little bit of separation between what these kind of companies do and what for example, a CSIP client aggregator is doing. And we're expecting that these distributed energy resources are going to expand across our network here in the United States and everywhere. And it's interesting to think about the fact that connecting to the network, and getting energy from that network exclusively is really maybe not the main model. We're actually seeing more balancing service, these ancillary services that these distributed resources can do. And what do we get in return for that? Well, service reliability. The grid becomes kind of an insurance or a backup for these guys. I think of like range anxiety for EV users. You can go to bed at night knowing that you're connected to the grid and you're not necessarily really worried about how much energy is in your battery. And so it kind of gives you that less anxiety about that. And so it's really interesting how the grid is evolving. We're seeing a shift in action from managing these generation assets to behind the meter assets. And here come the aggregators. These are demand response providers. And really they're being lauded as critical to the expansion of solar, where they essentially get all these solar services at scale and they're able to capture that modest value. And the model here is that the aggregators would share a portion of that profit that they achieve in this optimized portfolio. And indeed, you end up with this win-win situation where the consumer wins. They can depend on the aggregator managing their system for the stability of the grid, and the aggregator wins. They make a little bit of money, and the utility wins here too, because you're extending out the life of the utility. Tom, you can see there's a whole list of these aggregators out there that are forming with some very familiar names you might notice. Now, the next step here is that you're going to see sort of 3 different ways that these utilities are going to be communicating with our systems. One of them is direct inverter communications. That might be something similar to what APS is doing, where they're communicating directly with the installations that they're making. Folks out there get $35 or something per month for allowing their rooftop to be used for a solar system, and that type of control is being used today. But I think the second one here, where we're mediated by an energy management system controlling the DER, is really what we're talking about with the CSIP certification. And there's another model here as well, where the back-end system is in this case, we're seeing the aggregator, like I was talking about before, just in the last slide, managing a whole fleet of inverters across the utilities network. Now, let's talk a little bit about what the CSIP is. CSIP is fantastic. Essentially, let me just give it away. CSIP stands for Common Smart Inverter Profile. And essentially what the Smart Inverter Working Group, you can see a report that they put out there in 2014. This came about after there was some issues or worry about mass deployment of solar on the grid causing grid disturbances. And so this SIWG was developed, and they really came up with these new communication ideas and these new interoperability ideas. And this really informed the work and the new revision of Rule 21. And you can see their report there was put out in 2014. And it was their idea that if we could ensure incorporation at minimal expense, if we can kind of get all these inverters to have a smart interface, and so the utility can more easily communicate with them. And so California Rule 21 requires that all these systems utilize the 2030.5 networking standard as described in the CSIP. So that's your link. And the CSIP requires all these systems directly communicating be certified for these kinds of communicating and most important interoperability capabilities, SCADA-like, I will say, SCADA-like capabilities. And then the smart part of it is this two-way communication where, smart commands from the utility, a request, actually initiate the response that we expect and the appropriate behavior from the systems. That's the key thing. Why we're doing this. Yes, Tom.
If I can add a few comments here. The Common Smart Inverter Profile, I would say the roots of it really came out of work that was done, well, first in Germany and then ultimately in the US by EPRI to define common functions for smart inverters. For example, frequency operating windows, voltage operating windows, curtailment, scheduling, things of that nature. And so it started off with electrical functional behavior, and then the common smart inverter profile, that specifically was used to marry those electrical functions to the IEEE 2030.5 standard. The 2030.5 standard is quite broad, and so it would also govern the management of course, electric vehicles, pool pumps, hot water heaters, various other demand response devices, also provides price signaling, a great number of different functionalities. So what Common Smart Inverter Profile does is it hones in on those functions within the 2030.5 standard that relate directly with how to manage an inverter, and then sets up a template for how to do that. And so this then allows us to have far less integration in the field and allows us to do more in the way of in the factory certification, such that when the products are shipped, they are known to work well in the field.
Thank you, Tom. This is what the installers have tuned into here. They kind of understand what it is and what they need to do to not only what it is, but how they can bring it into their systems. And indeed, this is, you know, the bomb dropped on June 22nd, and there was a lot of folks that were finding that the inventory that they had no longer was certified for installation. And, you know, after June 23rd, really installers are obligated to start installing these inverters with advanced functionalities in these California IOUs. So, you know, what does an installer have to do? Well, they have to make sure that their products are certified to that UL 71 SA. They need to make sure that they have a certification to the CSIP requirements defined in the 2030.5 2018. And they need to make sure that their product's certified to something, the 1547 or later versions for conformance to test procedures from the NERDL. So this is really what the installers need to do. They need to go and look at their inverters, and at their inverters, they can confirm that this is a UL 1741 SA tested standard inverter. They can look at their data sheets. They can look for that SunSpec IEEE 2030-2018 CSIP certification badges. You can look for that. If you don't actually see it on the inverter nameplate, you'll definitely see it in the spec sheets. And then on the internet, you can look for the CC listing of the CSIP inverter and the SunSpec listing on their product registry. I might note that the Go Solar California website, where you might normally check this out, has migrated over to the new solar, the home partnership program. And so you'll see that if you were to go to that Go Solar California website, they'll direct you over to this new website. So as I noted, a quick way to go about this is really just to go back to that SunSpec CSIP certification registry. And you can see here that now I've checked my my CSIP certification registry, and you can see our card there. And again, you can grab the certificate, and you'll see that the entire product line of Solis from that 2.5 to 125 has that SunSpec 2030.5 Solis Cloud CSIP certification. And indeed, that is our mini client aggregator, essentially that second scenario of communication with the grid. And so you've now got an inverter here that's certified by SunSpec to that standard for wide area communications. You have compatibility with other smart interfaces with our SunSpec Modbus certification. And you can be assured that the entire product line is grid stabilizing, grid communicating type inverters that has that SA test, that is is designed for grid reliability and grid communications. It includes the smart inverter functions per 1547.1. It has a CSIP certification. And have some news about that as well. Of course, the SunSpec Rapid Shutdown and SunSpec Modbus. And so we're on board with this. We've got inverters ready for your installation across the nation. And we're looking forward to little Q&A with our team here. We've finished up the main portion of this webinar, but we're looking forward to getting some questions from y'all. We would like to find out what's on your mind and whether or not you're having any issues with this stuff. And so we'd like to open it up to see if we've got anything on those chat lines. Michael, do we see anything there?
You got one question from Luciano. What about some coordination or compatibility of SunSpec to some IEC standard? This looks like a question for Tom.
Sure. That's an easy one. So our standards work in terms of the inverter communication and DR communication was originally based on the IEC 62850 standard. And so all this work in 2030.5, of course, has its roots there as well. Now, as the U.S. has gotten ahead of the rest of the world on development of standards in this area, the functionality or the polarity has sort of switched to where the information that's coming out of SunSpec Modbus and IEEE 2030.5 is being fed back into IE 62850. And indeed, I was just on a call that indicated within the next 6 months, that standard will be updated to become compatible with these U.S. standards.
Excellent.
I also saw another question that came in about what do I mean about different product types, and it came up in the context of rapid shutdown, but it applies to 2030.5 as well. On the rapid shutdown front, you have transmitters and you have receivers, and the receivers are typically co-located with a solar module. A transmitter is typically co-located with the inverter. And so that's what it means in that context. There's transmitters and receivers, one closer to the inverter, one closer to the panel. In the 2030.5 context, you have clients, servers, and aggregators. So three types of products. And the client products are typically installed or embedded in gateways on a DER, a system site, and whereas aggregators and servers are run in a data center somewhere, could be in Amazon or Microsoft and what have you, but servers are run by the utilities generally, and aggregators are typically run by third parties to aggregate a number of clients to provide a consolidated view to the utility.
Thanks, Tom.
Indeed. And our Jinlong monitoring, for example, is an example of one of those client aggregators.
I have a question from Hunter. What are the distance limitations to the rapid shutdown devices?
I think it's 1,000 meters. I believe that's the limitation. And what governs that limitation is the fact that DC power lines are used, and so that's the limitation there.
Yeah.
Also, to add to what Tom mentioned, it's also depending on the number of parallel connected strings as well. So 1,000 meters is a general guideline, but if you have longer cables to some strings and shorter cables to other strings, there may be a slight difference in that. But it should be big enough for any rooftop application for sure.
Sure. If you need the particulars, go to sunspec.org and download the spec. Of course, the product manufacturers also provide the same type of information, but it's all available for you.
Excellent.
What is the efficiency of Solis inverter in rapid changing environmental condition?
As I showed for the 125 kilowatt inverter, you can see our efficiency is very flat. From 10% to 100% output, our efficiency varies maybe 0.5 to 0.75 percentage points. So we're just as efficient in rapidly changing lighting conditions, such as fast moving clouds, as we are in low light conditions. So our efficiency ratings for across the board are 97% or better, and that includes our single phase and our hybrid inverters.
A question from Mark. How does Solis handle commissioning of systems, both electrical and IEEE 2030.5?
Well, the electrical part is very simple. Our inside transmitters for the module level rapid shutdown are AC powered. So once you have AC attached to the inverter, you can turn on the AC switch that powers the module level rapid shutdown devices, but you leave the DC switch off, and that isolates the inverter and the strings from one another. On units with fuse holders, you would just basically open the fuse holders one at a time to check for open circuit voltage, or excuse me, close the fuse holders one at a time to check for open circuit voltage and make sure you have the proper polarity. And then you would just close those and then open the next, or close the next, open those, and work your way across the entire array. For single phase, a little simpler because we have direct connection. Typically, if you have 4 strings, it's going to a 4 MPPT inverter, and they're already isolated, so you can just turn on the AC and then check each string separately before you turn on the DC and make sure you have the polarity and voltage taken care of. Now, for IEEE 2030.5, that's done as not necessarily at a commissioning time standpoint. That's done by the utility, and that's something that we have to work with the utility with to confirm the operability as each site is installed. But we do confirm operability prior, that's part of the certification process, prior to the inverters being shipped out and received. Do you have anything else to add to that, Terrence?
Well, you can also check your rapid shutdown devices. Each one is somewhere around 0.6 volts. And so you can kind of check the overall functionality of your units by looking at a voltage number and kind of multiplying how many units you got out there. That can be sometimes useful as well.
Can system harmonics disturb your inverters?
Yes. Other things such as large rotational loads, like huge electrical motors that put out a ton of noise on the line, can also cause harmonics that can cause the inverters to not operate properly. That's nothing that we can control. That's according to the standard. We have to operate within specific harmonics and not generate those. And if they're outside the harmonic range on the grid, it can cause our inverters to operate irregularly or to turn off completely.
Are there cybersecurity requirements that will be enacted in tandem to these new smart two-way communication inverter requirements?
Tom?
Yeah, let me take that one. So yes, absolutely. At the outset, IEEE 2030.5, and by the way, I misspoke regarding the application of that standard. Yes, it's being used in the United States, but it is clearly an international standard and being used in other countries like Australia, for example. But back to your question about cybersecurity, the standard itself requires the use of digital certificates. And so SunSpec has set up a public key infrastructure provider for that purpose. So that is that level of security you can consider to be relatively basic. It covers over wire considerations, and there's a variety of other standards, like for example those that are being produced in the SunSpec Sandia Cybersecurity Working Group, which will be proposals for covering other aspects of cybersecurity. So in terms of regulatory action, it's all embedded within the standard. But again, assuming that distributed energy is going to be highly successful, you can expect other requirements to come in. So the industry is preparing for that right now.
Thanks, Tom. Yeah.
Do most of these standards apply to California? Do you have a tabulation of what standards apply for California and other states?
Sure. Maybe I'll tackle that one as well. So IEEE 2030.5 is embedded in U.S. law through the IEEE 1547 standard that was enacted in the Energy Act of 2006, I believe, that said IEEE 1547 would be used in all 50 states. Now, the compliance criteria, the test criteria, was published in 2020. And so this is so-called IEEE 1547.1. And so that publication date is a triggering event for the other 50 states to adopt that standard. And so the National Association of Utility Commissioners gave a directive to all 50 states to start their adoption of IEEE 1547.1 2020. So you can expect over the next 24 months to find this protocol being used. in every state in the union. Same goes for SunSpec Modbus, and to the extent where the DNP3 protocol is being used, which is primarily on the utility side, that is another one of the standards that is mandated via the 1547 standard. With regard to NEC 2017, I mentioned that's required now in 34 states, and the NEC itself has a map. We also have a map to show you where that's required as well.
Can we control the output through the cloud? Is the EPM configurable in the inverter?
Now, not all of our inverters, especially in the US, have a built-in export power manager. That's for markets outside the US. And that is a very good question. I can't answer whether or not you can configure the EPM externally through the cloud. I would have to refer that to our HQ, who is more knowledgeable of international products. There are other things you can control on the inverter through the cloud using this protocol, as Tom mentioned, and that is you can control inverter output, you can control your VARs, and you can control a frequency response, as well as output response to frequency or voltage, and to change those as well.
Is the 125 kilowatt a 480 volt unit? Can I curve trace with the transmitter active?
For the answer to the first question, the 125 kilowatt is a 600 volt AC unit, specific for larger scale ground mount systems. Curve tracing with, no, you can't curve trace with the transmitter. Definitely can't with it off. With it on, you may end up getting some feedback on that. We'd have to test that internally to make sure that there is no feedback on that, but that's a very good question that I can't answer at this moment. Any questions that we can't answer, please send your email address and we will follow up with those with our HQ.
Right. That's what we've done. We've set up this webinar to get those hard questions answered. And so we'll get them done.
It's like one last question. Any plans in 2020 to make available 208 volt inverters?
That's a very good question, and we get this question quite often, and my answer is always, what's the volume we're looking at? Because in the past, 4 years ago, we did offer 208 volt inverters in the US market. We sold exactly 0 of those inverters in the US market in 3-phase applications. So we get the question quite often. We do have models in the international market that we could certify for the US, but we would offer them as long as we had some guarantee of a market. Currently, no one has been willing to define the market for us so that we can understand more exactly what we're looking at. But that's another question that definitely send me an email and we will refer that back to our HQ as we gather data to look more into the 208 3-phase market.
Okay, one last question from Robbie. For IEEE 2030.5 and CSIP, are you incorporating the technology directly into the inverter, or are you connecting the inverter to a separate gateway that provides the IEEE 2030.5 and CSIP communications?
Right, that's the separate gateway. Essentially, that's our client aggregator, our Genlong monitoring, which acts as the interface for the inverter.
I just want to clear something up on the 208 volt question. Our single phase inverters will operate at 208 volt single phase if you connect them line to line. But as for, I was just assuming you meant a 3-phase application, 208 volt 3-phase application, and that is the one that I was referring to when I said we don't currently offer that in the US market.
And we sometimes see this question or the system design resolved through the use of a 480-208 transformer. And sometimes the cost of that transformer can be reasonable, and you can use our 480 volt inverters in that situation that way.
Yeah, I think that's it.
All right, thank you, Mike. Appreciate it. Tom, thanks for jumping in and going through that Q&A. That was very informative to all of our attendees today. You can see both the Jinlong Technologies and the SunSpec offices there. Please use that, use those emails, contact us, and make sure that your questions get answered by our teams. We're looking forward to working with you and making sure that you understand what CSIP is, what that impact is on your installations, what's coming down the pike, and why the grid is evolving in the way it is. It's fascinating stuff, and I'm really glad that you were able to join us today. We've run up against our hour here. Tom, thanks for coming and joining us today and providing your perspective on these changes in our PV universe here.
Thank you very much. I'm very pleased to be able to participate.
Bernie, again, thanks for your insight and joining me today on this webinar. And I'd just like to say thanks to all of our attendees today and look forward to working with you soon. Contact us with anything you've got going and keep that solar flying. Have a good day, everybody. Look forward
Thanks, Terrence.
to
Thanks, everyone.
Terrence.
webinar.